Hello my dear friends, how are you all? I hope you all are good and fantastic. So my dear friends, you are very welcome in our lecture number 5 of circle. Okay, so my dear friends, I hope you will enjoy this lecture. So without wasting the time, let's begin. So my dear friends, today we are going to discuss some important questions. Okay, so now let's see. Yes, so the question number 1 is, a tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q, so that OQ is equals to 12 cm, and we have to find length PQ. Okay, so now let's suppose we have a circle like this, and according to question, a tangent PQ at point P, let's suppose this is a tangent at point P. Okay, and point P of a circle of radius 5 cm. Now we know that this is center O and the radius is what? 5 cm. Meets a line through the center O at point Q. Okay, now according to question, from this point O there is a line to the point Q. Okay, now we have a distance of OQ which is 12 cm. Now we have to find PQ. Okay, so now in this figure, the line that is drawn from the center to the given circle to the tangent PQ is perpendicular to, okay, this is what? This is perpendicular. So OP is a radius and OP is perpendicular. Perpendicular to PQ by theorem 1. Okay, in theorem 1 we already seen that the tangent is perpendicular to the radius of a circle. Okay my dear friends, I hope you get this point. Now, so triangle OPQ is right triangle. Right triangle. Okay my dear friends, I hope you get this point. So with the help of this right triangle, we can easily find the value of PQ. How? By Pythagoras theorem. So we can write it here. OP is perpendicular to PQ. So using Pythagoras theorem in triangle OPQ, so we get OQ square is equals to OP square plus PQ square. Okay, hypotenuse square is equals to base square plus perpendicular square. Now we know that OQ, which is 12 square, is equals to, we know the value of OP, which is 5 square plus PQ square. Okay, now PQ square is what? 12 square minus 5 square. And what is the value of 12 square? 144. Minus what is the value of 5 square? 25. If we subtract this, we get PQ square is equals to 109. 19. Okay, so now this will become PQ is equals to under root 119 centimeter. So this is our distance PQ. This is our answer. Okay, my dear friends, I hope you get this point. So now let's move to the next question. Yes. From a point Q, the length of the tangent to a circle is 24 centimeter and the distance of Q from the center is 25 centimeter. The radius of the circle is. So now my dear friends, this question is similar to the question number 1. In this case also we have a circle like this and we have a tangent, okay, at point P, and this is a point Q and this point O, this is center. Now we know OQ is what? Is 25 centimeter and OP we have to find. And what is the value of PQ? PQ is 24 centimeter. Okay, so OP is perpendicular to PQ. Okay, so from this figure we have OQ, which is what? 25 centimeter. PQ is 24 centimeter, and now we have to find OP. So by using Pythagoras theorem, in triangle OPQ, then we get what? We get OQ square is equals to OP square plus PQ square. Okay, so now 25 square is equals to OP square plus 24 whole square. So with the help of this we can easily find OP square. So we get, what is the square of 25? 625 minus, what is the square of 24? 576. Okay, so we get OP square is equals to 49. So OP we have under root 49, which is equals to 7 centimeter. So the value of OP is what? 7 centimeter. Okay, so now let's move on. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degree. At an angle of what? 80 degree. Okay, my dear friends. Then angle POA is equals to. Okay, so now let's suppose we have a circle and from the point P, this is outside of the circle. From the point P, we have to draw two tangents. This is tangent. Okay, so this is A and this is B. Okay, and this is center O. So now we have to join this line and we have to join this point P. So we have two tangents PA and PB and two radius OA and OB. Okay, now we have to find angle POA, means angle POA, it means we have a line in the middle. So we have to find this angle, and we have given this angle is what? 80 degree. APB is what? 80 degree. So now my dear friends, in this diagram OA is a radius and OB is what? Is a radius, and we know that PA and PB is tangent. Okay, now we know that OA is perpendicular to PA. Okay, and OB is also perpendicular to PB. So we can say that angle OAP is equals to angle OBP, which is equals to what? 90 degree, which is equals to 90 degree. Okay, I hope you get this point. Now in quadrilateral, in the quadrilateral OAPB, in this quadrilateral, we know that the sum of all the interior angles, will be 360 degree. Will be what? 360 degree. The sum of all the interior angles will be 360 degree. So angle AOB plus angle OAP plus angle OBP plus angle APB is equals to what? 360 degree. Is equals to what? 360 degree. And we know that angle OAP means it is what? It is 90 degree. And angle OBP means this angle is what? 90 degree. And angle APB, which is 80 degree. So we can put all the values. Angle OAB plus 90 plus 90 plus 80, which is equals to 360. Okay, so now this will become, so my dear friend, this will become angle AOB plus 260 degree is equals to 360 degree. So angle AOB, if we shift 260 degree to the RHS, we get 360 minus 260. Okay, this is what? 100 degree. So we have angle AOB. Angle AOB is what? 100 degree. Okay, now my dear friends, we have to find angle. We have to find what? Angle POA, means this angle. So for finding this angle, okay, for finding this angle, we first of all we have to prove triangle, this triangle 1 means OPA and triangle 2 OPB. We have to prove these triangles to be congruent, so that we can say that angle OAP and angle BOP is equal, and we know the whole equal, we know the whole angle, and we can divide the whole angle by 2, so we get this angle, because these two angles are what? Equal. Okay, so now let's do that. So now in triangle OPB and triangle OPA, so we have AP is equals to BP. What? AP is equals to BP, because the tangents from a point are always equal. From a point are always what? Equal. Okay, and OA is equals to OB. Why? Because it is radius. and OP is equals to OP. Why? Because this is common line. Okay, my dear friends. So now we can say that. So now we can say that triangle OPB and OPA are what? Are congruent. So triangle OPB is congruent to triangle OPA. Okay, by what? By triple S rule. By triple S rule. So we can say that angle POB is equals to angle POA. By what? By CPCT. This is very important. Congruent parts of corresponding triangle. Okay. And we know that angle AOB is equals to angle POA plus angle POB. Okay. And we know that this is what? This is, yes, this is 100. And we know that these two values are equal. So we can write twice of angle POA, because angle POA is equals to angle POB. Okay. So now this will become angle POA is equals to 100 upon 2. So we get what? 50 degree. We get 50 degree. So angle POA is equals to 50 degree. So this is our answer. So I hope, my dear friends, you understand these things. So now let's move on. So the next question is, prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Passes through the center. Okay. Now if you observe that in previous lecture we learnt about the properties of a circle. So this is the one of the properties from those properties. Okay. So what is the question is saying? So the question is saying that we have to prove, let's suppose we have a circle. We have a circle. Prove that the perpendicular at the point of contact to the tangents, and we have a tangent. Now from this point, the perpendicular line is passing to the center of a circle. Means if you draw a perpendicular line from this point, then it will always pass to the center of a circle. This is perpendicular, this is center O, this is point P, and this is point R, and this point is what? Q. Okay, so now my dear friends, O is the center of a given circle. O is the center of the given circle. Okay, and a tangent PR, this tangent PR, okay, is touching the circle at point P. Okay, so and we have QP is perpendicular to RP. QP is perpendicular to RP at point P. Okay, I hope you get this point. So now OP is perpendicular to RP such that point Q lies on the circle. Okay, my dear friends. So now angle OPR is what? 90 degree. Okay, because radius is perpendicular to tangent, and also angle QPR is also is equals to what? 90 degree. Okay, so we can say that angle OPR is equals to angle QPR. Okay, this is what this is given. So now from now this case is possible only when center O lies on the line QP. This case is only possible when the center O lies on the line QP. Okay, my dear friends. So now this case is possible only when center O lies on the line QP. Okay, my dear friend. So perpendicular, yes. So perpendicular at the point of contact to the tangent to a circle passing through the center of the circle. What? Hence perpendicular at the point of contact to the tangents to a circle passes through the center of circle passes through the center of circle. Okay, my dear friends, so this is the proof of above question. Okay, so now let's move on. So the next question is, two concentric circles are of radii 5 centimeter and 3 centimeter. 5 centimeter is the radius of the above larger circle, and 3 centimeter is the radius of smaller circle. Find the length of chord of the larger circle. Means we have to find the length of chord of the larger circle which touches the smaller circle. Okay. Okay, my dear friends. So we have a two concentric circle. Okay, these are the circles. Now in the two concentric circle, O is the center of these two circles. Means O is the common center of these circle. Now we have a larger chord AB, chord of the larger circle AB, which is touches at point P. At point P. Okay, so now AB is the tangent of the smaller circle. AB is what? AB is the tangent of the smaller circle. So we can write here as AB is the tangent of the smaller circle at point P. Okay, so we can write as OP is perpendicular to AB by theorem 1. Okay, so now we know that the radius of larger circle is 5 centimeter and the radius of smaller circle is 3 centimeter. So the what is the value of OB, which is 5 centimeter, and what is the value of OP, which is 3 centimeter. Okay, so now with the help of Pythagoras theorem we can easily find the value of PB. Okay, we can easily find the value of PB. Okay, now so using Pythagoras theorem, in triangle OPB, we can write it as OB square is equals to OP square plus PB square. Okay, we know the value of OB, which is 5 square. We know the value of OP, which is 3 square, and we have to find PB square. So we get what? We get PB square is equals to 25 minus 9. Okay, we get 16. So PB having the value of under root 16, which is equals to 4 centimeter, which is equals to what? 4 centimeter. So we have PB is equals to 4 centimeter. So with the help of Pythagoras theorem, PB is 4 centimeter. Now my dear friends, if you remember that in previous lecture we learned a property which says that what? The perpendicular from the center of a circle bisect the chord AP. Okay, bisect the chord AP means what? The chord of a larger circle in two concentric circle. Okay, the chord of a larger circle in two concentric circle which touches the smaller circle at point P is the bisector. Means AB is what? AB is a tangent of the smaller circle and chord of the larger circle, which it touches at point P of the smaller circle. It means that AP is equals to what? PB, and this perpendicular line bisect this chord. This perpendicular line OP is bisect this chord AB. Okay, so we can say that. So we can write here as, so my dear friends, we know that since okay the perpendicular from the center of the circle, okay, bisect the chord, it means AP is equals to what? PB from this above statement. So we can say that AB is equals to twice of PB. We can write it here as, so we know that the value of PB, which is 4, and 2 into 4 is what? 8. So AB is equals to 8 centimeters. AB is what? 8 centimeters. So this is our answer. This is a what? Answer, which is the length of the chord of the larger circle. So my dear friends, I hope you understand these things. So now let's move on. Yes, so the next question is, xy and x dash y are two parallel tangents. This xy and x dash y are two parallel tangents to a circle with center O. Okay. And another tangent AB. Another tangent AB. This is this, which is at point C. With point of contact C intersecting xy. Intersecting xy at A. At A. And x dash y dash at B. Okay, so this line AB intersect xy at A and x dash y dash at point B. So now we have to prove that angle AOB is equals to what? 90 degree. Okay, so now let's start. Yes. So now my dear friends, if we observe this figure, in this figure we have to do a small construction. What? We have to join OC. We have to join what? OC. So now this diagram will become, this point is this is a line OC. Now the triangle OPA and triangle OCA. Okay, now in triangle OPA and OCA. Okay, this triangle 1, this is a triangle 2. OP is equals to OC because they are radius. Okay, AP is equals to AC because, listen to me very carefully, AP is equals to AC because these are the tangents from a single point. So we can say that AP is equals to AC. AP is equals to AC. So these are tangents from the point P, from the point A. Okay, from the point A. Okay, my dear friends, and AO is equals to AO, which is common. Which is what? Common. So now we can write as triangle OPA is congruent to triangle OCA. By what? By triple S rule, side rule. Okay, so similarly we can write as OQB is similar to congruent to triangle OCB. Okay, similarly we can write here as triangle OQB is similar to triangle OCB. Okay, my dear friends, I hope you get this point. Now, my dear friend, from these two statements, we can see that we can write that this angle is equals to this angle by CBCD, and this angle is equals to this angle by what? By CPCT. Okay, my dear friends, so now here is angle POA is equals to what? Angle COA. Okay, this angle POA is equals to angle COA. Okay, we can write here by CPCT. Similarly, we can write angle QOB is equal to angle COB. This is again by what? By CPCT. Understand, my dear friends? So, and we know that the line POQ, the line POQ is what? Is a diameter. Means this is what? This is a straight line, and we know that the straight line, and this is a point O. So the angle is from point O. This angle is what? 180 degree. So we can write here as angle this and angle this, this and angle this. The sum of all these angle is what? Is equals to 180 degree. So we can write here as angle POA plus angle COA plus angle COB plus angle QOB, which is equals to 180 degree. Okay, because line POQ is a straight line. Okay, so now from these equation number 1 and equation number 2, we can write here as what we can write? We can write as twice of angle COA plus twice of angle COB is equals to what? Is equals to 180 degree. Now take 2 as a common. We get angle COA plus angle COB is equals to 180 degree. So it will become angle COA plus angle COB is equals to 90 degree. Okay, now we know that angle COA, okay, and angle COB is what? Angle AOB. Okay, is what? Angle AOB. We can write here as angle COA plus angle COB is equals to angle what? Angle AOB, which is equals to 90 degree. So my dear friends, I hope you understand these things. So this is our answer and hence proof. Okay, my dear friend, I hope you get this point. So now let's move on. So my dear friends, so the next question is prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. First of all, in this case, we have to draw a diagram. Okay, let's suppose we have a circle. This is a circle which having a center O. Now this is a point P. From this point there are two tangents. There are what? Two tangents. Okay, this point is P and two tangents are PA and PB. Okay, my dear friends. So now join A to B. Join A to B, which make AB. Okay, my dear friends, and join this radius, this center to this point. Okay, my dear friends. So now from this diagram, we can see that the line segment OA, is perpendicular to AP, and line segment OB is perpendicular to BP. So we can say that from this diagram we can say that what? So angle OAP is equals to what? 90 degree. Is equals to what? 90 degree, and similarly angle OBP is equals to again 90 degree. Okay, so now in quadrilateral, OAPB, in quadrilateral OAPB, we know that the sum of all the angles is what? The sum of all the angle is 360 degree. So we can write here as angle APB plus angle OAP plus angle PBO plus angle BOP, which is equals to 360 degree, which is equals to what? 360 degree. So from this we can write as, now we have to putting the values, now we have to putting these values to this equation. So we get angle APB plus 90 plus 90 plus angle BOA is equals to 360 degree. So we get angle APB plus angle BOA is equals to what? 360 minus 180. So we get 180. So we have angle APB plus angle BOA is equals to 180 degree. So now my dear friends, this is the part which we want. Okay, hence proof. Okay, I hope my dear friends you understand this point, that the angle between 2 points, between 2 tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. Means this angle and this angle are supplementary angle. What are supplementary angle? So my dear friends, I hope you understand these things. Okay, now my dear friends, this is enough for today, and based on these questions you can do any type of questions based on this topic, based on the tangents, circles. Okay, so now thank you very much guys for listening me, and we will meet in the next lecture with the next amazing topic. Okay, so take care and goodbye.